How does that work?
Okay, so we're looking at like y equals x to the 2/3 versus y equals x to the 3/2. In short, it's because this first one.
Oh, right, it can't be negative. Isn't...
Right.
Yeah.
So let's graph these with broad strokes, right? So we think like x to the 2/3 looks like at least this much, right? Because 2/3 is less than 1, right? And the question is, what's going on to the left, right? And I can write this as like x to the 1/3 squared. And can't stop me from taking a cube root. And so we get one of these deals.
Yeah.
Okay. And if you really want to understand this, what's the graph of x to the 1/3 look like?
It would be... I'm not sure.
So everything is centered around y equals x, right? For p bigger than 1, where we have y equals x to the p bigger than 1, the right-hand side of this graph always looks like this.
Okay.
Okay? For p less than 1, the right-hand side of the graph always looks like that. And I'm being careful to indicate that between 0 and 1, taking a square root makes things, let me do a different color here. Taking a square root makes things larger.
Okay.
And I'm saying taking a square root when I really mean taking any root. Like 1/2 to the 0.91 is bigger than 1/2.
Right.
Right. And 1/2 to the 1.1 is smaller than 1/2. That is reflected by my little football shape.
Okay.
Right there. And that makes sense? Okay. And then, of course, this middle thing is y equals x. That's always what happens on the right side.
Okay.
Okay. What happens on the left side in the event that the denominator of p is even is nothing. Okay. So if p is anything over an even number, you get nothing to the left.
Okay.
Right? If p is even over an odd, you'll get this, or you'll get this.
Okay.
Okay? And that makes sense when I draw that. And if p is an odd over an odd, you'll get either this or you'll get, again, I'm careful to indicate the football nature of what's going on between 0 and 1. Why did I leave out P equals even over even?
I'm not sure.
Because I would always reduce that fraction.
Okay.
If it was even over even. Okay?
Alright.
So that's your IQ test question of the day.
Okay.
Okay, so if you're on board with this, then you get it. The other thing I'll mention is that, like if you have y equals like a x to the p, I guess it changes this point.
Okay.
Right? Because when x is 1, you'll get a.
Alright.
Right? Does that make sense? And then, of course, you can add c, and you can do this a times x minus 5 to the p plus c. Juggles it left and right and up and down. But it's always these coefficients that are potentially tricky with these toolkit functions is what we called them in pre-calculus back in my day.